Those four components are what we found inside. We bought the 6 most popular plug-in energy-saving devices sold online. StopWatt, Miracle Watt, Pro Power Save, EcoWatt, VoltBox, and one with no brand name. We paid between $29 and $49 each. Then we opened each one on the workbench. Inside every device were the same 4 things: a common capacitor, the size of a thumbnail, a cheap varistor, the kind that provides less surge protection than a $10 power strip from the hardware store, a flimsy plastic case, and a green LED. That LED is the most insulting part. It exists only to glow, making you feel like the device is doing something. In fact, that little light is the only component inside the box that actually consumes electricity, meaning each one of these devices, technically, it increases your electric bill the moment you plug it in. These products are sold under dozens of brand names, and they all promise the same. Plug this box into the wall, and your electric bill drops 40% overnight. Some ads use fake endorsements from Elon Musk or Leonardo DiCaprio. Some create entire websites designed to look like CNN or Forbes. Some even forge official government emails, and in total they've generated millions in revenue. But here's the key question: do they work? And if not, how is this scam constructed, and what does it exploit? On Historia Prime, we often journey deep into the past. Lost survival skills, forgotten hygiene habits, how our ancestors solved problems with what they had. Today, we still do that, because this scam isn't new. It is built on a brilliant piece of 19th century physics that most people have never heard of. And to understand why the scam works psychologically, you have to understand why the physics works electrically. So let's go back, not to the internet age, but to the 1890s. Part 1. The Wizard of Schenectady. In the early 1890s, America was wired for a war. Not a gun war, but a technology war. Thomas Edison was pushing direct current. George Westinghouse championed alternating current. History calls it the War of the Currents, and AC won. Because AC could travel hundreds of miles over wires where DC couldn't, but early AC electricity had a problem that no one could fully explain. Engineers at power plants noticed that the amount of electricity they generated didn't match the amount reaching the factories. Energy was disappearing. Somewhere between the generator and the destination, the numbers simply didn't add up. The man who solved this problem was Charles Proteus Steinmetz. Steinmetz was a German immigrant who came to the U.S. in 1889. He was born with kyphosis, a severe spinal curvature, and stood only 4 feet tall. But his mind operated at a level that amazed everyone he met. He first worked for Rudolf Eichemeyer, an inventor and manufacturer of transformers in Yonkers, New York, in 1893. The newly formed General Electric Company bought Eichemeyer's company, partly for the patents, but mainly because they wanted Steinmetz. GE moved him to Schenectady, New York, where he spent the next 3 decades revolutionizing electrical engineering. In his time, he was anything but obscure. The press called him the Wizard of Schenectady. He served as president of the American Institute of Electrical Engineers. He was one of the most recognized scientists in the country. What Steinmetz discovered through meticulous mathematics using complex numbers was that alternating current carries more than one type of electrical power. And to explain what he discovered, engineers have used the same analogy for over a century. It's simple and perfect. Think of a glass of beer. The liquid beer, the part you actually drink, is called real power, measured in watts. This is the electricity that does actual physical work. It heats the coils in your toaster. It produces light in the light bulb. It turns the motor in your washing machine. Real power is the only form of electricity you pay for on your home utility bill. The foam on top of the beer glass is called reactive power, measured in var. You can't drink the foam. It doesn't quench your thirst, but it takes up space in the glass. Reactive power is a kind of imaginary energy. It is absolutely necessary to create magnetic fields inside electric motors and transformers. Without it, the compressor in your refrigerator cannot start, but reactive power itself does no useful work. It just oscillates back and forth between the power plant and your equipment, 60 times per second, like a tide that never reaches the shore. The entire glass, liquid plus foam, is apparent power, measured in volt-amperes It represents the total electrical demand placed on the grid. The ratio of useful beer to the total glass is called the power factor. A perfect power factor of 1 means your glass is 100% liquid and 0% foam. A poor power factor of 0.7 means 30% of your glass is foam. The grid must send you a much larger glass just to provide the liquid you actually need. Steinmetz not only identified the problem, he found the solution. He showed that connecting a device called a capacitor to the circuit acts like a sponge for the foam. The capacitor stores electrical charge and produces a current that cancels the reactive current from the motor instead of imaginary energy. Reactive current flows back to the distant power plant, but capacitors recycle it right on the spot, next to the machinery that needs it. In the 1920s, large industrial plants across the United States used arrays of capacitors to correct their power factor. It saved them huge amounts of money. It was a true success of applied physics. But here is the key question that scammers hope you never ask. If this technology works so well for factories, why doesn't it work the same for your home? Part 2. The billing trick they count on you not knowing. The answer lies in one word: meters. Utility companies are not charities. When a large steel mill with thousands of heavy motors creates a huge wave of reactive power, that ghost energy clogs the utility's transmission lines, heating up the wires. It wastes infrastructure capacity. The utility has to build larger cables and transformers just to handle that froth. So utilities fight back. They install specialized complex meters at factories and commercial buildings, meters that record both active energy in kilowatt hours and reactive energy in kilovolt ampere reactive hours. If the plant's power factor drops below a threshold, usually around 0.85, the utility charges them a power factor surcharge. It can add thousands of dollars to the monthly bill. By installing large capacitor banks, factories correct their power factor, avoid penalties, and save real money. This is a well-documented and understood industrial practice. It has been standard for decades and is the tiny kernel of truth on which the entire consumer scam is built. Here is what the scam ads will never tell you. Your home's electric meter does not work the same way. Whether you have the old mechanical meter with a spinning disc or a modern digital smart meter, residential meters in the United States are designed to measure only active energy. They only measure the liquid beer, completely ignoring the foam. In the United States, Canada, the United Kingdom, and nearly every developed country in the world, residential customers are billed only in kilowatt hours. You do not pay power factor penalties at home. You do not pay for reactive energy, period. So when you buy a $30 plug-in capacitor and plug it into a wall outlet, technically, it might improve the power factor of the wiring inside your home by a very small, almost immeasurable amount. In theory, this could reduce the current flowing through the wires inside your walls by a tiny fraction, meaning the heat losses in those wires decrease slightly. We are talking about savings of only a few cents per year, far less than the cost of the device itself. Your electricity bill won't change by even a single cent, because the power company never charged you for reactive power in the first place. You are buying medicine for a disease you don't have. This is the 21st century version of snake oil from 19th century hucksters. Part 3. Amps Tricks. How they fake the demonstration. If you've watched any advertisement videos for these devices, you may have seen the demo. A salesman plugs a fan into a kilowatt meter. The display shows a current of 0.5 amps. Then they plug their magic box into the same outlet. The reading on the meter drops to 0.3 amps. They look at the camera and say, "Look, a 40% reduction." This is not exactly a lie, but worse. It's a half-truth designed to deceive you. Here's what the demonstrator did. They deliberately set the meter to show amps, measuring total current, instead of watts, measuring actual power. Because the capacitor inside the scam device neutralizes some local reactive power, the total apparent current from the outlet actually drops. That part is real physics, but at that very moment, the phase angle of the current changes. Your electricity meter bills you based on voltage times, current times, the cosine of the phase angle. The drop in current is mathematically canceled out by the change in phase angle. The actual wattage consumed, the only thing your meter records, the only thing you pay for, remains exactly the same. It's a magic trick. The demonstrator shows you the foam shrinking while the beer stays the same size. But since you only pay for the beer, the shrinking foam doesn't change your bill. Part 4. Fake news, deepfakes, and psychological warfare. When physics doesn't help them, scammers turn to psychology. And they are alarmingly good at it. The marketing infrastructure behind these devices is sophisticated. They create entire fake news websites, designed to look exactly like CNN, Fox News, and Forbes. They post fabricated investigative reports, claiming the device is a breakthrough. They use unauthorized images and AI-generated deepfakes of celebrities, Elon Musk, Leonardo DiCaprio, Joanna Gaines, to imply celebrity endorsement. To be clear, none of these people have anything to do with a $30 plastic plug. Tesla's energy division sells the Powerwall, a sophisticated home battery system costing thousands of dollars, not cheap capacitors in plastic casings. Some of these operations even send scam emails, spoofing official government addresses to gain consumers' trust. Local authorities are mandating the use of these devices. They exploit financial fears. They create power where none exists. They manipulate basic math into something that sounds convincing to anyone who isn't an electrical engineer. It's a textbook case of digital fraud. And it works because the underlying physics is complex enough that most people can't easily verify the claims themselves. Part 5. The part that should really scare you. On Historia Prime, we talk about survival, knowing which water is safe to drink, how to detect danger before it gets close to you, how to fortify your shelter against threats in the modern world. Survival means keeping unregulated hazards out of your home, and these devices are exactly that. These products are unbranded. Items are shipped directly from suppliers, bypassing the rigorous safety testing required for legitimate electrical devices. Sold in the United States in April 2022. The UK Office for Product Safety and Standards has issued official recalls for many energy-saving plug devices. The recalls cite serious fire and electric shock risks. Testing revealed incorrectly sized plug pins and can break inside wall sockets, unmarked, unapproved capacitors with a high risk of short circuit. No internal fuse or proper protection, meaning if there's a power surge, the device has no way to fail safely, it simply catches fire. In 2025, a UK consumer group tested 8 more such devices purchased from Amazon, eBay, AliExpress, Shein, and Temu. None of the devices produced any measurable energy savings. All failed safety standards. Testers found poor soldering, excessive lead content, and non-compliant construction throughout. Think about what that means. You're stressed about rising costs. You spend $30 or $40 hoping to save your family a few dollars a month. And in doing so, you plug an unregulated, untested, potentially toxic fire hazard directly into your home's wall. The device that was supposed to protect your budget could burn down your house. Part 6. What actually works? The financial pain is real. According to data from the U.S. Energy Information Administration, residential electricity prices have risen about 28% nominally from 2021 to 2025, from about 13.7 cents per kilowatt hour to over 17.4 cents. Residential prices rose 9.5% in the past year alone. The causes are structural: aging grid infrastructure requiring hundreds of billions in upgrades, extreme weather events with costs passed on to consumers, and the explosive growth in electricity demand from AI data centers and electrification. We cannot control the macroeconomics of the national grid, but we can control what happens in our own homes, and the solutions are not mysterious or hidden. They are well documented, scientifically verified, and available right now. LED lights are a simple upgrade. Incandescent bulbs waste about 90% of their electricity, generating heat instead of light. LEDs convert almost all their electricity into photons. Switching your entire home to LEDs can cut your lighting costs by up to 75%. No magic, just better engineering. Smart thermostats. Heating and cooling are the biggest energy users in most American homes. Smart thermostats learn your schedule and automatically adjust when you leave or sleep. The Department of Energy estimates smart thermostats reduce HVAC costs by 8 to 15% annually. That's real measurable money back in your pocket every month. Phantom load. Many modern electronics, like TVs, game consoles, phone chargers, never fully turn off. They are in standby mode, silently consuming power, day and night. The Department of Energy estimates that standby power accounts for 5 to 10% of residential electricity use. Simply unplug unused devices or use smart plugs that cut power completely can save a typical household $50 to $100 a year. Sealing and insulating. This is the oldest survival skill, reinforcing your shelter against the elements. If your home leaks air through gaps in doors, windows, and attic, your HVAC system works harder than necessary. Adding weather stripping and upgrading attic insulation can permanently reduce your heating and cooling bills by up to 15%. Real-time energy monitoring. If you really want to understand where your electricity goes, don't buy a fake capacitor. Buy a legitimate home energy monitor. Devices from companies like Sense or Emporia safely clamp onto the main wires in your breaker panel and connect to your phone. They don't magically clean your power. They show you in real time exactly how many watts each device is consuming. Consistent research shows that when people can see their consumption in real time, they change their habits and achieve real savings of 5 to 20%. None of these solutions promise 40% instantly. They require some effort, some investment, and some patience, but they work. They are backed by engineering, not marketing. One thing we never do on this channel is pretend that every problem has a DIY solution. If your electricity bill suddenly spikes and you can't explain why, the answer may not be upgrading your thermostat or a set of LED bulbs. It could be faulty wiring, damaged equipment drawing too much power, or a meter error. These are issues that require a licensed electrician with proper diagnostic tools if you suspect something is truly wrong with your home's electrical system. Call a professional. No YouTube video, not even this one, can replace a professional inspection. In conclusion, today we started at a workbench, opening a plastic box. Inside we found 4 cheap components and a blue LED designed to make you feel like something is happening. But to understand why that box exists, we traveled back in time to the 1890s and met Charles Proteus Steinmetz, the Wizard of Schenectady. His mathematics explained how alternating current really works. We learned about real power and reactive power. We learned about beer and foam. We learned that power factor correction is a real industrial technology that has been around for a century, saving factories millions of dollars. And we learned exactly why it doesn't save homeowners a single penny, because your residential electric meter never measured the foam in the first place. The scammers selling these devices didn't invent new technology. They took a piece of mainstream physics and wrapped it in fake news articles, deepfake celebrity endorsements, and staged urgency. They're not geniuses. They're just counting on you not knowing the difference between amps and watts. Now you know the difference. Next time someone sends you an ad for a magic plug-in device, or your parents ask if they should buy one, you'll know exactly what to say. You'll know about beer and foam. You'll know about the meter. And you'll know that the real way to lower your electric bill is not a $30 plastic box, but knowledge. That's what this channel is all about. The best survival skill in any century is understanding how the world really works. If this investigation helped you see things a bit more clearly, share it with someone who needs to hear it. That's how we fight scams. Not with devices, but with information. Thank you for watching. I'll see you in the next episode.